Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this subtopic, we will be looking at what is thermometric property, how to calibrate a thermometer, and what are the characteristics of a quality thermometer. In the previous lesson, we have looked at a few examples of application of thermal equilibrium in our daily life. We are going to talk further in details about thermometers. Before that, is there any difference between temperature and thermometer? What is temperature? Temperature of an object is a measure of the average kinetic energy of its particle. When both objects reach the same temperature, the transfer of energy stops because the average per particle is the same in both. And here at the diagram, higher temperature goes to lower temperature region. Principles of thermometry. A thermometer is any instrument which is used to measure temperature. The thermometer needs a scale to be used effectively. There are several types of thermometers. The choice of which to use is depend on three criteria. The first one, the range of temperature to be measured. The second criteria is the accuracy. And the third criteria is the physical conditions in which the thermometer will be used. Here is a situation in a lab. Hey, this thermometer doesn't have a clear scale. We need another thermometer. This thermometer can still be used. We just need to calibrate the thermometer. Okay, so now these students will calibrate the thermometer. A thermometer that doesn't have a scale can be calibrated. We use two fixed temperature points, which is 0 degrees Celsius as melting point of ice, and we use boiling point of water, which is 100 degrees Celsius. Here is how you carry out the activity. Step 1, place the thermometer into a beaker of ice. Observe what happens. Record the reading. Mark 0 degree on the thermometer. And then place the thermometer just below boiling water. Mark 100 degrees Celsius on the thermometer. Remove the thermometer from boiling water. And then place the thermometer at a substance that you want to measure. Before that, divide the scale into 100 divisions. So this is what you will get. The bulb of the thermometer shouldn't touch the base or side wall of the beaker while taking measurement. Why is that? Can you think of it? Discuss your answers with your friends, and maybe you can share your answers at the comment below. The answer to this question is, if the thermometer bulb touches the container, the temperature that we measure is the temperature of glass, not the temperature of the solution. So readings may be incorrect, particularly if the flux is on a hot plate or in an ice bath. Okay, after we carry out the activity, we can get the unknown temperature by using this formula. From the activity, we have ice point, which is L0, and then we have steam point, which is 100 degrees Celsius. We'll note this was as L100, and then we also have L theta. So the temperature theta can be calculated as L theta, which is the length of the unknown temperature, minus L0 over L100 minus L0 times 100 degrees Celsius. Thermometric properties. Some materials have properties that changes with temperature. Liquids can expand if the temperature increases or contract if it decreases. Metals and alloys also expand and contract if the temperature changes. Some substances change their colors when temperature increases. Some substances change their electrical conductivity when its temperature changes. Then we need to know a few characteristics of thermometer. First is responsiveness. How long it takes for the thermometer to react to change in temperature. The second characteristic is the sensitivity of the thermometer. This measures the amount of change in thermometric property per unit change in temperature. And the third one is the range. This refers to the scope of temperature it can measure. And then we need to know about the linearity. It is the uniform expansion of the liquid to temperature. Liquid in glass thermometer, we need to have thin wall glass bulb. And then we need to have a small bulb and fine and uniform bore. Next, we want the thermometer to have thick wall tube and it must be smaller size. Now let's look at thermocouple thermometer. This is a diagram of a thermocouple. The probe contains two different metals joined to form two junctions. The temperature difference causes a tiny voltage which makes a current flow. A greater temperature difference gives a greater current. Thermocouple thermometers are used for high temperatures which change rapidly and have a large range, which is about -200 degrees Celsius to 1100 degrees Celsius. If the junctions are at different temperatures, a small electromotive forces or EMF is produced. The larger the temperature difference, the larger the EMF produced. The temperature range over which a thermocouple operates depends on the two metals used for wires. For example, if we use copper, we will have different range, and if we use constant wire, it will have different range. Notice also that we use a very sensitive voltmeter. Here are some advantages of a thermocouple. It has a very wide range. As the wire junctions are very small, the thermocouple can be used to measure the temperature at a point. And then, due to small mass and small thermal capacity of the thermojunctions, the thermocouple can be used to measure temperature that change very rapidly.